Native Code. Hello, this is Isaac Fauché, and I am part of Native Code Creator, along with Rebecca Croysdale, Christian Mann, and Roy Simons. We're just going to be talking about kind of how our application has been developed and how it all works behind the scenes today.
The application is created for high school students who do not currently have access to quality computer science curriculum, giving them an opportunity to learn how to code through this app. The application is created with React because we want the UI to resize for different screen sizes so that different types of phone can use our application.
This is the outline of our lesson system. When a user interacts with the system, they will choose a lesson from a list provided by their instructor. The available lessons to choose from will be dependent on their progress on previous lessons as a sort of prerequisite so that topics can build off of one another. Next, they will be shown an overview of the topics that will be covered, along with the necessary teaching materials provided by the instructor. Once a user feels they have a sufficient understanding of the lesson's concept, they will be presented with a blockly environment along with a task to complete based off the topic of the lesson. When they have completed their attempt at the task, their implementation will be graded. If the user receives a failing grade, they will be returned to the blockly environment for another attempt. If they receive a passing grade for the challenge, they will be rewarded with a card to be used in the card game. We also allow a user to return to a lesson they have already completed, in the case they want to apply concepts learned from future lessons to find an alternative solution to the challenge.
Our project structure is set up in this form. As you can see, the white is stuff that is finished, red is stuff that we haven't gotten to yet, and yellow is stuff that is pretty much finished, just lacking some features. We have the main menu that goes into a lesson view, which utilizes a Blockly editor. The Blockly editor communicates with the grading proxy server, which is connected to our Intel NUC. The lesson view is also connected to a lesson database, which populates the view with all of the lessons. The main menu can navigate to the user login screen or the user registration screen. Currently, the user registration screen just checks to see if a username has been entered before, as upon entering a username in a user registration form, it creates a folder for users' code to be stored in. Currently, user login has a page but doesn't go anywhere.
So here we start in our app at the login page where students can log in right here. They type in the name, password, log in, or they can register, create a username, make a password, see it gets checked if it's there. If it's not there, they can create an account. We also have buttons here right now that should not be in the end stage. They're here just for development so that we can easily navigate around. Let's go to the home page. In the home page, we have a button for lessons, a button for card games, and a logout buttons. We also have settings, but since we do not have any settings currently available, we do not allow the user to click on it. Let's go to the card game. The card game is currently just a placeholder. This will be a project for an online capstone team that will start working on this spring term. Now let's go back to the home screen. Then can allow us to go to lessons, which will be talked about later. Then we have our main hamburger menu, which allows the user to switch between home, lesson, card game, or logout at any moment. They can do it from home itself. They can do it from the lesson. They can do it from the card game, allowing them to navigate at all times. Uh, for the UI, we used an open source React toolkit called Blueprint.js. It allowed us to have different symbols, the same style for buttons, um, and it also allowed us to give visual feedback for when uh, a user wants to click on something, like it underlines, and it has a red for logging out for a serious click, and it will give a feedback that you have clicked on a button. Now Rebecca will talk more about other stuff from the UI.
So I implemented React routing. So I'm going to show how that works in the UI and in the code. So everything that we see in the UI is a React component. So this button is a component. This bar up here is a component. So the way the router works is it sees the URL and it makes sure the correct component is showing. So for example, right now the URL is just a /, and so the login menu is showing. And if I were to click on register, then the URL changes to /register, and the register screen shows, as you can see over here. And all of this routing happens in a component called app.js, and that app.js is rendered from index.js. So that means that everything we see on all of the website is inside of the router, and that's why you can have the header and footer just shown in one place. You don't have to redo anything that you want to be on every single page. So that's really nice. So in short, the router maps each URL to a React component. You can see that most of these routes have this exact keyword, so that they all show the exact path shows that component. But for lessons, we didn't want to have a whole bunch of code for every lesson that says /lesson/lesson1 show lesson 1. So to make it more dynamic, we have the :lesson ID here, and we removed the exact keyword. So this :lesson ID makes it so that on the lesson screen component, we can have lesson ID is this.props.matchparams.lesson ID. So if I were to go and look at a lesson, we can see that since the database is not running at the moment, we can see our default undefined lesson, and that shows up in the URL, and it shows up on the UI because the goal and the hint and some other things are loading. Yeah, and so that's basically how routing works and why we used it. And the other thing I worked on was I made this toolbox over here toggleable, because our goal for this website is that it can be used on phones, and this toolbox here, which is where you get blocks out of, it takes up a lot of horizontal space on a phone, so it's important that we can hide it. So you can see in the UI, if you click the button, it makes it hide. This actually ended up being pretty difficult to do because this area here, this component, was not created by us. It's called React Blockly, and so I had to look through the React Blockly source code, but eventually I figured out how to do it by using the Chrome DevTools to inspect the rendered page, and I found that this part of the component is a class name, and so I can do this code over here to find that exact component and change the display style to none or block, depending on the state of this button.
Here's kind of an outline of our database. In front of you here is the SQL source file used for the initial insertion into it, which also contains the schema and general structure, which we'll go over. Before that, though, I want to talk about what kind of database we decided to use. Initially, we were going to use MySQL, but with some issues with configuring it and setting up a server really slowing down development, it just didn't seem like the best option. Isaac eventually suggested us check out SQLite, which ended up being much better, as it's not only is it more lightweight than MySQL, which is perfect for keeping everything on a Intel NUC, it is also file-based, so we didn't need to host a whole other server just to access our data on the same device. While SQLite might not have as many capabilities as MySQL, it's perfect for our intended use. Sadly, this also involves some less security, but for what we need, it shouldn't be too hard to implement that. The way we will query the database is through our proxy server. This file in front of you contains the routers for the GET requests for which the React server will send for, in order to get the information for the lessons, to display them on the lesson menu in the lesson Blockly environment. This first router here is to get all lessons. It will send this SQL statement to the server, and after getting a lock on it via the Node.js package, it'll store the result in a JSON file, indicating whether it was a success or failure, and then sending that to the React server. To get a single lesson is very similar, except you're asking for a specific lesson ID, which changes the SQL statement slightly, but the data is stored and sent in the same way in a JSON file. Here's an example of how the React server would request it. It would send, to get all lessons, it would send to this URL, which is currently at port 5000, and then it would return a JSON with all the lesson data. Let's say we wanted to get the data for a single lesson. We would just request for a specific ID, and it would return just that for us, saving some time and resources so we don't have to, in the case we have over almost 100 lessons. This file contains the React code for querying the proxy server to get the information from the database. So it'll call a fetch request, requesting that URL we showed earlier, then storing that JSON file within the state of this React component. It will then load via this HTML string and dynamically load every lesson file. An example of this is shown here in the lesson menu, showing the 3 lessons that were showed earlier. Once the user clicks on one of those buttons on the lesson menu screen, it'll then send them to this page with the actual Blockly environment. The way this is loaded is after the server sends a request to the proxy server, depending on which button was pressed on that page. It'll save the ID, request that, and then load it via this HTML here.
So here in the server.js file, we find how we are actually running our backend commands as of now. We use this command, run command, which basically takes in an argument for a command and then what we should do with the information we get from running said command. This is utilized for our grading script as well as our registration and future login stuff. The grading script works by using a printf with the user's sent code into a user's folder underneath P code for Python. Currently, the user ID is hard-coded to 4387, but this can be changed in the future. It is then ran backend run Python script with the arguments for what lesson the user is trying to complete, as well as the code that the user has written. And then we go ahead and remove the generated code afterwards here. Inside run Python script, what we do is we cat in 2 files into one file, here, script.py, and then we add on to the end if the name equals main, then we run grade. After that's been made, we then run the script with Python here. An example of a grading script for one of our demos is here. So we have the define grade. We set the results equal to user code, which isn't actually a function yet, which would result in an error. But if we go over here to a past ran grading attempt, script.py, we see that the concatenation actually builds a function called user code, and then whatever the student tried to return in their function. You can also see the if name equals main, and then it runs grade, which is up here defined at the top. And that's only if we're running this Python script like this from the command line or in a bash script. To see this in action, we go on over to our native code creator applications. We'll go ahead and select lessons here, and then hello world. Now you can see the goal of the lesson is to create a program that will print out the text hello world. Now unfortunately we have printing disabled because it will interfere with our grading script, but we can get around that by using a return statement. We go ahead and select hello world, copy that, paste it in here, and go ahead and send grade code. So what will be sent to our grading server is this text here generated by Blockly. So we're going to hit grade code, and our results are true. And you can see over here in our terminal what the server has received. So it received this, lesson 3, and then this code. And now, if we go here and look at our script, it is actually changed to hello world instead of something else. So if we do something incorrect instead, so if we say hello planet and hit grade code, we will get a return false, as well as this getting updated in their script.py. How user registration currently works is by doing a make directory with the input for the username, and then basically printing success if the make directory was successful, or failure if it wasn't. This checks to see if a username is already taken and can be seen over here. We go to home, log out, and we go to register a new person. My name is Isaac, so I will put my username as Isaac, and I'll put my password as password because that's a great password. We'll go ahead and hit register, and we get this nice prompt that says user created, and then here in the bottom right we see that it indeed was Isaac with the password password. Now if someone else came along and thought they could have the username Isaac and decided to type in a insane password such as this and hit register, they would be greeted with a username taken, and if you can see here, their password is gibberish. Now, one of the things that took a while to get set up was this actual Blockly environment itself. Now, we have our initial XML set to this function here, and also if you look at some of the properties here, we see that it's set to edibles false, and where the X and Y values are going to be. We also have a temporary toolbox that says AI category for the future, but unfortunately right now all it has is one empty string box. When the workspace changes, we actually set our console to what the new XML of the workspace is. This is mostly for debugging at the time. As you can see here, we open up the console, and every time the workspace is updated, we get a new XML. We can use this to create new defaults for levels or lessons and stuff like that. Down here we just have the render function, which sets the initial XML and how the workspace should be configured. In the future, we will have XML loaded instead of from here from the database. But until then, it's just this default value.